Wow, today is the lovely day. Look at that fish.
Wait, Nani, don't jump. It's dangerous.
Today, I want to introduce about free-falling body motion. First, a free-falling body motion is defined as the vertical motion of a body at constant acceleration under gravitational field without a resistance. Second, in the Earth gravitational field, the constant acceleration g is also known as acceleration due to gravity or free fall acceleration. Third, free fall is defined in Newtonian physics as the motion of a body in which gravity is the sole force acting on it. A body in free fall has no force acting on it under general relativity, where gravity is reduced to a space-time curvature. In this chapter, we have four formulas. 1. V equal to U minus G times T. 2. S equal to 1 over 2 U plus V times T. 3. S equal to U times T minus 1 over 2 times G times T power of 2. 4. V power of 2 equal to U power of 2 minus 2 times G times S. Of study is to determine the maximum height of the object from any point. Second, to determine the time taken by an object while falling with certain velocity and height. Third, to determine the gravitational acceleration by studying the velocity of falling object as a function of time.
Question: if Nani jumps straight up into the air from a 3-meter high bridge at 15 meters per second, she will reach a peak before falling all the way down into the fish pond below. Since she just barely missed all the edge of the bridge on her way down, we can track her path step by step to calculate exactly how high she flew, how long she stayed in the air, and how fast she was moving right before she hit the water. We need to calculate A. The maximum height reached by Nani from point P. B. The time taken from point P to Q. C. Time taken from point P to point R. D. Time taken from point B to S. And E. The velocity of Nani when she reached point S. Figure. As we can see in this figure, here is the visual path of Nani's jump. Point B is where Nani starts her jump on the bridge, which sits 3 meters above the water surface. She flies out to point Q, which represents the highest peak of her flight, where her velocity stops momentarily. On her way back down, she passes point R, which is at the exact same height as her starting point on the bridge. Finally, she lands right into the fish pond at point S at the very bottom. By mapping out these key points, we can break her motion down step by step to solve our questions easily. Let's solve part A to find the maximum height reached by Nani. To do this, we use the formula V squared equal to U squared plus 2AS. Our initial velocity U is 15. Our velocity at the top V is 0 because she stopped for a split second, and acceleration A is negative gravity, which is negative 9.81. Plugging in these numbers give us 0 equal to 225 minus 19.62 S. After calculating, we get S equal to 11.47 meters, which means Nani flies 11.47 meters high above a starting point.
Question B asks us to calculate time taken from point P to point Q. For this question, we will be using formula of S equal to 1 over 2 multiply with U plus V and multiply with P. Then, we add the values that we have into the formula. So, it will be 11.47 equal to 1 over 2 multiply with 15 plus 0 and multiply with t. Then we will get 11.47 equal to 15 over 2t. After that, we will move to the left. Lastly, the answer for t we will get is 1.53 seconds. Next, we move to the question C. This question asks us to calculate the time taken from point P to R. For this question, we will be using the formula of S equal to UT minus 1 over 2 GT power of 2. Then, we add the values that we have into the formula, where U equal to 15 and S equal to 0. So, it will be 0 equal to 15t minus with 1 over 2 multiply with 9.81 and multiply with t power of 2. Then, we will get 0 equal to 15t minus 4.905t power of 2. After rearrange the question into standard quadratic form, it becomes 0 equal to negative 4.905t power of 2 plus with 15t. By solving this equation, we get two values for t, which are t equal to 0 and t equal to 3.06. Lastly, since time cannot be 0 for the entire journey, so the final answer for t we will get is 0.3.06 seconds. For question D, the question asks us to calculate the time taken from point P to S. For this question, we will be using the same formula, which is S equal to UT minus with 1 over 2 GT power of 2. Then, we add the values that we have into the formula, where S equal to 3, U equal to 15, and G equal to 9.81. So, it will be negative 3 equal to 15t minus with 1 over 2 times 9.81 times t power of 2. Then, we arrange the equation into standard quadratic form and it becomes 4.905t power of 2 minus with 15 and minus with 3 equal to 0. By solving this quadratic equation, we will get two values for t, which are t equal to 3.25 and t equal to negative 0.19. Lastly, since time also cannot be negative, the final answer for t we will get is 3.25 seconds.
Question E. Find the velocity of Nani when she reached point S. In this question, we have U equal to 50, G equal to 9.81 and T equal to 3.25, and we want to find V. So we use formula V equal to U minus GT. Then we substitute the U, G and T in the formula. Then we get V equal to negative 60.88 meter per second. The answer is negative because Nani is moving downward.
So, for the conclusion, firstly, kinematic equations are applied to analyze the motion of objects in free fall. Second, a free-falling object moves downward because of the force of gravity. Next, during free fall, an object experiences a constant acceleration of 9.81 m over s power of 2. Finally, when an object is released from a certain height without being pushed, its initial velocity is 0 m over s. That's all from us. Thank you.
Relax, Mia. I just want to see fish. I don't want to jump. Oh, that's good.